So we're going to do some examples here with arc length. So a couple things that we have to know before we start is, I've got my notes up here from arcs, but remember that circumference is the distance around the outside of the circle, and that is 2 times pi times the radius. So, or you can make that pi times the diameter. So these are what you have to know in order to be able to do these problems. We just abbreviate this circumference by c. So actually we just call it c. But I'll leave it there as circumference so that way you can see it. Now, moving on to the question, it tells us a circle has a circumference of 10 and it has an arc length of 9/2. So it's asking us to find the angle in this case. So one other formula that you did in your notes is that if you want to find the arc length, not the angle of the arc, but the actual arc length, you can do that by taking your angle, so whatever your central angle is, you divide by 360, and you multiply it by the circumference, which in this case is 2 times pi times the radius, or pi times the diameter, but I'll just put c for now. So solving this problem, we want to find the arc length, we want to find the central angle of the arc. So I'm actually trying to solve for that angle there. So I'll just take my formula and start plugging some stuff in. So I know that my arc length is 9/2, which is 4.5. I know that my circumference is 10. So I have to solve this equation. So the first thing that I'll do is I'll divide both sides by 10. So if I do both of these sides divided by 10, 4.5 divided by 10 is equal to the other side divided by 10. Now if I do that, 10 divided by 10 is 1, so I am left with just the angle divided by 360. Now if you can't do 4.5 divided by 10 in your head, just move the decimal place once, but 0.45. So you get 0.45 is equal to the angle divided by 360. I'll just copy and paste that over. Now, in order to get rid of this 360, I'm going to have to multiply both sides by 360. So times 360 on this side, times 360 on this side. When you do that, you end up with 162 degrees. So our angle is 162 degrees. Which makes sense because this pink angle here is less than 180, but it's still very big. So that helps us know that we did this correctly. Moving on to the next question, I'm going to leave my notes up here. Our circle has a radius of 6, and arc in this circle has a central angle of 48. What is the length of the arc? So I'm asked to find arc length. I know that my radius is 6, and I know that it has a central angle of 48. So I'm going to take my angle here, that's going to be 48. Now, it gives us a radius, so this circumference right here, I'm actually going to have to fill in my formula. 2 times pi times the radius. I'm going to have to take that and put that in here instead of c. So now I should be able to solve this question. So I'll take this formula and copy it down and substitute in 6 for my radius. Now all of these are numbers, so I should be able to find what my arc length is just by plugging all these into the calculator. So I've got 48 divided by 360 times 2 times pi times 6. And I end up with 5.03 when you round that here to the nearest hundredth. So 5.03, and in this case, I don't know what my unit is, but 5.03. And we should be okay. So let's just check and see if we entered that correctly. So sometimes when you're doing these on the computer, they ask that you enter them in a very specific way. So I use the pi button on the calculator, but in order to make the answers match up, I think what we're going to have to do is use 3.14. So if I go back into my calculator and instead of pi, I do 3.14, put a multiplication sign here, and then times 6, I may end up with a slightly different answer, so 5.02. So I think that's why this came out incorrectly here. So just pay attention for that. It also says you can put the answer in terms of pi. What that would mean is entering it as, everything here multiplied except leaving the pi. So if you had done 48 over 360 times 2 times 6, and then just leave it with a pi, 1.6 pi or 8 pi over 5 would have been an appropriate answer as well. So anyways, moving on to the next question. So this one asks us for an arc length as well. So let's just leave our formulas up. So it says our circumference is 12, and I have an arc with a 48-degree central angle. So very similar to our last question. So I'm going to take my angle and input 48. I know that my circumference is 12. So I should be able to just calculate this pretty quickly. 48 over 360 times the circumference of 12. That gives us 1.6. So because this is equal to 1.6, I should be able to go over here and 1.6. Moving on to my next question. This one I have to solve for the angle again. This is a good one for us to do. So I start with my formula. And it says that the circle has a circumference of 20 and it has an arc length of 4. What is the central angle? So how much of an angle opens up to an arc length of just 4 here? So let's put in 4 for our arc length. And we can substitute in 20 for our circumference. Now I just have to solve this formula, or this equation. So because I'm trying to solve for the angle, I need to get rid of this 20 over here. So maybe what we should do is divide both sides by 20. So you could do this. The equation doesn't want to let me put another fraction in here, but we can. I'm basically going to divide both sides by 20, and then same thing over here. This 4 I'm going to divide by 20. So once you do that, 4 over 20 should just get you 0.2. So 0.2 is equal to the angle divided by 360. So the 20s cancel out, and all you're left with is this angle over 360. From there, you want to multiply both sides by 360 because you want your 360s to cancel out over there. So I'm going to multiply both sides by 360. And you end up with 72 degrees. So 72 should be equal to my angle, and which would also be the angle of this arc. So 72. Here we go.